Hi, everybody. We're going to get started in just about half a minute. Let's let folks come in. Can everyone hear me? I want to do a quick audio check. Okay, awesome. So the audio seems to be working. So let's get started. So welcome to this session where we're going to focus on introductory data science, and we're going to have a Python focus. And today specifically, we're going to be learning how NumPy and Pandas work. Now, these are words that you have never heard about. Don't worry, we're going to explain everything. You're going to be in good shape here. So just a quick introduction about myself. My name is Giri. I go by GPAL. I'm a self-taught programmer, and since the start of 2018, I've been offering these classes online, and I've taught over about 4,000 students or so. And this is something that I love doing. It's always great to meet new students and to teach Python and data science, and these are things that I absolutely love. Now, what's the game plan for today? So today we have an hour. That's not a lot, but we can get quite a fair bit done. And the focus is really going to be on mastering the basics of data science. I want you to be comfortable working with packages like NumPy and Pandas such that you can go on your own and download data sets and start doing preliminary analysis on your own. So first of all, we're going to focus on NumPy and then Pandas, and then we're also going to have practice exercises throughout the session. So just to give you a quick sense of how I structure these classes. So the first thing I believe in is that the best way to learn is to practice. So make sure that you don't just watch this lecture or this class passively. Try to do the exercises together with me. That's the best way that you can learn. And the second idea is the 80-20 principle. And the principle is that given the short time that we have, we need to prioritize. But that being said, 80% of the value in programming comes from understanding 20% of the concept. So we're going to focus on the most important 20%. And the third idea is that it's really nice when you can learn alongside peers. They give you encouragement, they help you debug. So that's what I hope to foster here as well. When you're done coding, try to help others, post your questions on the YouTube channel section or Discord community. These are places that you can connect with fellow peers. So there are going to be two tools we're going to be using. The first is our Discord server app, and second is the Google Colab. That's going to be the IDE, the place that we're going to be programming today. So let's go and get started. So the Discord server is the place that you can ask questions, and it's also the place where we can get updates on the class as it happens as well. So if you haven't signed up yet, go ahead and click this link. Go ahead and type this up, tinyurl.com/let's learn club. So let me show you the important channels that you need to know for today. So go ahead and sign up for a Discord server app. And let me show you the most important channels that we need to you need to know for today. Okay, so let me highlight the most important channels before we get started. So the first channel is going to be the class announcements channel. This is where I'm going to be posting all the official announcements. After the class, I'm going to be posting the class notes here. So important note, you don't have to take notes here. I'm going to share the notes with you later. Then the most important channel after that is going to be the programming exercises channel. So this is the place where you can post your questions, you can share your code and connect with others to work out your doubts and move on. So this is an important channel. So you can type in your questions here. Okay, so that's our Discord server app. So go ahead and sign up if you haven't. And let's move on to the tool that we're going to be using to code today. It's called Google Colab. and it's a cloud-based Jupyter notebook. So a Jupyter notebook is where a lot of data scientists work with. It makes it really easy to leave comments, to code as well. And the nice thing about Google Colab is that it allows us to code on the browser itself. So you don't need to download anything. And it also allows you to share code very easily. So let's go ahead, sign up, and write our first line of code. So what you do is you go to Google itself, type in Google Colab, click the first link, right? So for Google Colab, you do need to have a Google account. So if you do have a Google account, great. But if you don't, quickly sign up for one. It shouldn't take you that long. And then hit New Python 3 Notebook. And this is where we are. Let's just wait for a while. So anyone having any issues signing up? Okay, so has everyone successfully signed up for a Colab? Can we move on to the next step? Any issues so far? Okay, so let's move ahead. So I want to kind of show, I mean, there are many different features of this Jupyter notebook, this Colab notebook here, but I want to show you the important things that we need to know for today. So the first thing is that in this Jupyter notebook, you can either write code or you can write text. So you usually write text if you need to explain something. So let's just go ahead and create our first text block, and let's just say, this is intro to Python for data science. So we want to give it a clear label, and let's hit bold. Okay, so we're creating our first text block here. Okay, and the thing with these text blocks is that they work like HTML. I mean, we don't need to focus on this too much, but let's say we just want to center this. We use HTML tag to achieve that. Okay, great. So you write text to explain what's going on, to demarcate different sections, to explain the logic behind what you do, so that eventually, when you take a look at this code, you can make sense of it, and others can make sense of it as well. Apart from the text block, there's also the code block, and that's what we have here. And this works like any other Python programming shell per se. So let's say we can type in a comment. Let's say we want to type in print. Let's start with hello world. And then to run this code block, you go to this left side and hit this play sign. And then that specific code block gets executed. So that's how, so these are the important things you need to know. The next thing I want to tell you is you can share your code with others. So to do that, you put share, and then you get the shareable link, and then you can share it on our programming exercises channel. You can share it with others if you have any doubts along the way. So that's, I mean, there are many different other features with Colab, but these are the things that we need to know for today. So that will be good for today. So you can change the name of the notebook as well. Class practice. Okay, so let's go ahead and get started. So the first thing we want to do is to import the packages that we're going to be using for today. So there are going to be two packages that we're using. The first is NumPy, and then the second is Pandas. So to do that, what we do is let's just say importing packages. Then we say import NumPy is NP, and then import Pandas as PD. So what are we doing here? So in this cloud environment, NumPy and Pandas are preloaded. We don't have to download them, because if we were to do this in our own local environment, we need to pip install. So meaning we need to install the package and then import it. But in this case, these packages are pre-installed. So that makes it a lot more convenient for us. So all that we need to do is to import these packages. And what's happening here is that this is convention. And so usually people don't refer to them as NumPy and Pandas within the code itself. They use this short form, they use this alias. So that's what this is doing. So when you refer to this package, you don't need to call it NumPy, you just can call it NP or PD when we write code itself. Now, so go ahead and run that, and you shouldn't have any issues. So let's go ahead and write the next code block. Let's start diving into NumPy. So NumPy's, the main object that you're working with is called an n-dimensional array. So an array is similar to a list, but it's also in many ways superior to a list. So the nice thing, so let me show you what we can do. So chances are you're familiar with the way lists work. For example, let's say we have a company, and let's say we have data for the last 8 quarters, right? And let's say we have this list called rev list, which is the revenue in, let's say, $1 million for 8 quarters. Let's just create some random values. Okay, so these are completely random values. Let's say we have 8 quarters worth of data. And let's say we also have the cost list, right? Also in millions for 8 quarters. Let's initialize this list first. Okay, these are all random values. Don't worry about the specific numbers here. I just want to show you what you can't do with lists that you can in fact do with NumPy arrays. Now, so we have the revenue list and the cost list. Now, suppose you want to know the profit. And what's the profit? The profit is equal to revenue minus cost. That's the profit, right? Now, to do that, let's say you want to get the profit. So let's say we create this thing called profit list, and then we say rev list minus cost list. Now that's going to throw an error, because let's just do it nonetheless and see what error we get. Okay, so what's the type error? So we get a type error, and it says unsupported operand type, and it says that you can't just subtract from a list. So the thing that we realize right away is that when you want to do arithmetic operations on lists, it's a little inconvenient. Now you can create a list comprehension to make this happen, but it's going to look really messy. It's not a nice way of doing it. But now with NumPy, it becomes a lot easier to do these kinds of arithmetic operations. So what you could do is, what you need to do is you need to convert a list to a NumPy array. So the way that you go about doing that is to say, let's create a new variable called rev array, which stands for revenue array. And then we call NumPy dot array. And then we need to insert a list. So let's insert this rev list first. So let's proceed on to create a cost array as well. Let's convert this list into an array as well. Array cost list. Okay. And remember, our goal is we want to know the profit for each quarter. And what that means is we want 300 minus 250, 350 minus 280. So we want that in a separate, sorry, this is supposed to be cost array. And we want that in a separate array. So let's do that. Let's write profit array equal rev array minus cost array. Okay. Let's run that. Let's print that out. Profit array. Neat, right? So now, with just one operation here, we could subtract we can do arithmetic operations on these arrays. So that's really convenient. And suppose you want to know, in addition to subtraction, you can do the normal addition, subtraction, exponents, multiplication, division, so on. Suppose now we have this profit array, right? And suppose you want to find out the profit margin, and the profit margin is equal simply to profit over revenue. Now with NumPy, that's also super easy, right? You create a new array, profit percent, profit margin, let's call it array, and you say profit array divided by rev array. So it does this element-wise arithmetic, and it's a lot more convenient than using lists. So that's one big advantage that you get when you use NumPy array. Another advantage that you get when you use NumPy array is that it's a lot faster. So that's something that you need to take note why it's faster. So the thing with lists is that you can include objects that are of different data types. You can have integers, you can have floats, you can have strings, you can mix them together. But the thing with NumPy arrays, though, is that you need to make sure that all the objects are of the same data type. So they all have to be integers or they all have to be floats. You can mix and match data types. So that's also another reason why NumPy is a lot faster than lists. So two big advantages when it comes to using NumPy. It's a lot easier to do arithmetic operations, and the second is that it's a lot faster, and the improvement in speed becomes a lot more obvious when you have a much bigger data set that you're working with. And so far we have done basic arithmetic operations on these arrays. So suppose now, so what do we have right now? We have the revenue array, we have the cost array, and then we have the profit margin array. Now, suppose you want to know the specific quarters in which the revenue is greater than 300 million. So 300. So all these digits stand for a million. So the way that we can do that is we can say, look, print rev array greater than 300. So let's take a look at this first and let's see what we get. Let me comment all of this out before that. So what do we get? So now we get a Boolean. So essentially we are able to filter the array. So we are saying, give me the elements that are greater than 300. So what happens here is that it goes about evaluating, okay, is the first element greater than 300? No, it's false. Second element greater than 300? True. So we have a list of Booleans. Now, if we want to output the specific variables and not just get the Booleans, the way that we get that is we say print rev array. We take this list of Booleans and we subset the revenue array by that. So we say rev array, square brackets, and then we say rev array 300. Now, this is going to print out the specific elements in which the revenue is greater than 300. Yeah, there we go. So take a look at this. Our initial revenue array had all these values that were also less than 300, but in this specific revenue array, we are able to just filter out those revenue array elements that are greater than 300. So this is, I wanted to show you how you can filter out elements in an array itself, in a NumPy array. So the next thing I want to teach you is how you can see the shape of your data and kind of be able to reshape it accordingly. So if you want to see the shape of your data, this is what you do. Okay, you say print, and you enter the name of the array that you're interested in. And in this case, we're interested in rev underscore array. And you say you want to access the shape property. You print that out. And what do you see here? You see two spaces, but the first digit is 8 and the second digit is just empty. So what does this mean? How do you make sense of this? So the first digit is the number of rows that you have in the array. And the second space, the second part here is the number of columns. So in this case, what do we have? We have 8 rows and no columns at all. So let's say we want to shape the data differently. So right now in our array, what do we have? We have 8 quarters, right? So we have data for 8 quarters, and let's say we want to shape it such that we have 2 rows and each row represents a year. So how can we do that? So the way that we do that is we say print again rev underscore array, and we use this method called reshape. Let's put that in, and then we enter the number of rows that we want, and we want 2 rows, and then enter the number of columns that we want. We want 4, so this should add up to 8. Let's run this. Neat. So now what has happened? We have taken this 8-row array and reshaped it such that it has 2 rows and 4 columns. So this is row 0. Python starts with 0. So this is row 0 and this is row 1. And in total we have 2 rows and then we have 4 columns as well. So we have reshaped the data. Now the thing is, you can also, so right now we have this is called a 2-dimensional array. We can also reshape it such that it's a 3-dimensional array. So what we can also do is we can say print rev array reshape. Let's say we want it to be 2 by 4 by 1. Okay, let's comment this out and let's run this. So what do we have here? It splits into 2 first, and then we have 4 rows, and then within that we have 1 column. So the thing I want to share here is that the moment you have more than 2 dimensions, it becomes a little hard to visualize. So the way that I like to see it is, especially when it's 3-dimensional or 4-dimensional, try to visualize. So people have a good intuition when it comes to 2-dimensional. When it comes to 3-dimensional, not so much. So the technique that I like to use to make sense of higher dimensional data is whenever the higher dimensions, just think of them as almost different boards of just different sets of 2-dimensional arrays. So that helps you grasp what's going on with the data. So that's a trick that I like to use. Now, the thing you need to notice is that when we apply this reshape method, we don't actually change the shape of the underlying array itself. So in this case, we have reshaped it to be 2, 4, 1. It's a 3-dimensional array right now, but if you take a look at the shape of the underlying array, it's still going to be the same 8-row and no column. So let's say we want to assign, right? So if we want to store, we need a variable to store this 3-dimensional array. So if we want to do that, let's just create a variable called rev array, and let's type in reshape. Okay. Now, if we access we need to take out the print here, right? And then now we can see rev array reshape shape. Oops. Okay, so this is reshaped, but it's reshape. Okay. Put a small typo here. Okay, let's print this out now. Okay, neat. It's working. Okay, great. So what have we learned so far? We have learned how to get the shape attribute from the NumPy array. We have learned how to reshape the data as well. Now let's learn about how you can subset from a single dimensional array. So remember, we have this data set of 8 quarters, right? That's what we have right now. Suppose you are interested to know the just the first quarter from the first year. So in this case, you need to slice the single dimensional array. So how do you go about doing that? So let's create a variable called first_q first year. The way that we do that is it's very similar to the way lists work. So we take the array of interest And because Python does zero-based indexing, if we want the first quarter, we enter 0. Let's print out first Q, first year. Okay, let's print this out. So we get 300, which is the right response. But suppose we want to get the first 3 quarters, right? How do we go about doing that? So in that case, we just say print. I'm not assigning it any variable for speed. So we say we want to get the first 3. So we want the 0 element, the first element, and the second element. So we use the colon operator to get that. So we say we don't insert anything here, start, we just leave it empty, and then we put 3. And just to recap for those who are familiar with Python or for those who are new to Python, when we use this colon operator, note that the end operator isn't, the end element isn't outputted. So in this case, what gets outputted is 0, 1, and 2. But that also corresponds to the first 3 quarters. Okay, let's run this. And then we see just the first 3 elements being printed out. Now, you can also perform mathematical functions on NumPy arrays. So I want to show you some of the key mathematical functions that you can perform on NumPy itself. So going back to our revenue array, we have 8 quarters of data. Let's say you're interested to know the total sum, the total revenue for the 2 years, for the 8 quarters. What you do is you say print, and then you need to call the NumPy module. And then you put sum, and then you insert the array that you want to sum up. So in this case, let's say we want to sum up rev array. We hit that, click play, so we get 3300. And let's say we want to get the average. We can also do that. Okay. And another function that's also very handy is median. So let's put median. So these are pretty key functions that you can use in NumPy. I mean, of course, this isn't exhaustive, but I just wanted to give you a preview and a sense of what you can do with NumPy. So that was a very quick run through of what you can do in NumPy. The thing is, NumPy is extremely critical because other packages such as Pandas and SciPy are built on top of NumPy. So having a sense of how NumPy works helps you understand these other packages a lot better. So with that, let's move on to Pandas. That's where we're going to spend the bulk of our time. Moving on to Pandas. Let's move on to Pandas. So, people often ask me, how do we make sense of Pandas? The best analogy that I can offer when it comes to Pandas is almost like a spreadsheet. So the thing is, in Pandas, you work with these objects called data frames. So the data frames are kind of like spreadsheets, but I mean, they offer you a lot more customizability. You can do a lot more interesting things than spreadsheets. And Pandas is built on top of NumPy. And it offers a range of powerful functions that really help you simplify data analysis when you have large data sets. Now, the first thing you want to do is, whenever you want to work with Pandas, you need to typically get a data frame. You need to get the data. How can you go about getting the data, right? So the first thing you can do is that you can convert a dictionary into a data frame. One way you can get data is to convert a Python dictionary, into a data frame. So suppose you have a dictionary like this. Let's say we have a sample dictionary, right? And let's say in this dictionary we have, let's just simplify this. Let's just say A. Okay, let's just say A. Okay, 1. I'm just going to create a sample dictionary real quick here. because I want to show you how you can convert a dictionary into a data frame. And then after that, we're going to get the data from a CSV file. Okay. And let's say these are the keys, A, B, C, D. And let's say we have another row. And then we'll stop here, and then we will convert this into a data frame. Okay, let's just say 100, 200, 300. Okay, cool. So we have the sample dictionary, and let's say we want to create a data frame from the dictionary. So what we do is, let's say we have create this new variable called data frame. DF is short form for data frame. Okay, data frame from dictionary equal. So if you want to convert a dictionary into a data frame, what you do is you say PD dot, PD stands for pandas, data frame, and then you insert the dictionary, right? And let's say we want to see this data frame now, we just print it out. So what do we have here? The keys, so what happens here? The keys in the dictionary get converted into columns, right? So you have A column, B column, C column, D column, and the rows here in this list get converted into rows in the data frame. So data frame here is almost like a 2x2. This data frame, I mean, has columns and it's two-dimensional, right? It has columns and it has rows. Now the thing is, often you wouldn't be converting dictionaries into data frames. Rather, what's going to happen is that you're going to be getting data from a CSV file, which is a comma separated file. You might be getting data from an Excel file, from a text file, from an HTML file. So you're going to be importing data that way rather than getting it from within a dictionary itself. So I want to show you how you can get data from a CSV file. And specifically, from here on, we're going to be using this data set from Shark Tank. It's a list of deals that were done in Shark Tank. I'm not too sure how familiar everyone is with Shark Tank. I'm going to explain that briefly, but I want to show you how you can get data from a CSV file, first of all. So if you want to get data from a CSV file, we create a data frame first, and then we say PD dot read underscore CSV. And in this case, we are getting it from a link itself. So I'm going to share the link with y'all right now. So here's the link to the, so I'm going to share that on the YouTube channel real quick, and then the Discord server as well. Okay, so this is the link. I'm going to explain how this works in really quick. So go ahead, and this is the link. So I've added the link in both the comment section as well as the top chat section, and I'm sharing it on the Discord server app right now as well. So this is the link to the CSV file. Anyone having any issues getting it? So that's the CSV link that you need to key in. So type in PD dot read underscore CSV, and then insert the link in string. Okay, great. I want to just wait for another 15 more seconds, make sure that everybody can view the link and can load it up in their Colab space. Okay, let's keep moving ahead. So what are we doing here? So we have this CSV file. So I've created this link for a CSV file, so that makes it a lot more convenient for us to download the CSV file. And what's happening is we are reading from the CSV file. If you have an Excel file, it's going to be read underscore XLSX. So it's going to it's going to be, if it's HTML file, it would vary accordingly. But in this case, we have a CSV file and we're reading that CSV file. Now, whenever you read a CSV file or any other file for that matter, you want to get a macro view of what's happening. So the way that you can do that is, very important here, you need to run this code first so that the df variable gets initialized. So make sure you run this button. Okay, now let's move on. So like what I said, you want to have a macro sense of what's happening in the data. So the first thing that I would do is I would take a look at the shape of the data. So how do you access the shape attribute of a data frame? You put df.shape. So let's enter that. So what do we see? Like what I said with NumPy, the first element is the number of rows and the second element is the number of columns. So right away we understand that in this data set we have 495 rows and 19 columns. Okay, that's great. Let's say we want to dig a little deeper. What do? We say print. We say df.info. So we run that method on it. Let's run it. So we get a sense of what are the different columns here. So I want to explain very quickly how Shark Tank works. I'm pretty sure that most of you are familiar with, but if not, let me just run a very quick clip and then let's come back and explain, take a look at all these different columns of the data that we have here. So here's a very quick 30-second preview of how Shark Tank works. Okay, so you get a gist of how the show works. So essentially what happens is entrepreneurs come in, they pitch ideas to these Shark Tanks who are venture capitalists, and then they request a specific amount. Sometimes a deal happens, sometimes a deal doesn't happen. So I want to quickly explain the variables that we have here in this data set. So the first variable that we have is called deal. A deal stands for whether a deal did happen in the show or not. There's a description, an episode, category that the idea belongs to, the names of the entrepreneurs, the location, and then, there are many other variables. I want to quickly run through the important ones. Asked for is the amount that the entrepreneurs asked for. Exchange for stake is the percent stake that they were willing to offer in their company, to give up in their company, and valuation is the total value of the company. And these are the names of the sharks. And then finally, multiple entrepreneurs stands for whether this was just a single venture or in fact multiple entrepreneurs were involved in this. Okay, so that gives you a macro sense of what's going on. We see the different columns and we understand also the data type that's involved. So when it comes to a deal, we know right away that it's a Boolean. So it's either true or false. But when it comes to, let's say, valuation, it's an integer. So you get a quick sense of what's going on. But the best way to really understand it is to see a few entries, to see a few rows within the data. So what you do is you say print df.head and you run it. So what happens is that this pulls you the first 5 rows of the data frame, right? And you see the specific row values as well. So for the first row, you find that the deal didn't happen. You have the description, Bluetooth device implant for year, it's episode 1. You see the categories, the entrepreneurs. You see the valuation, the names of the sharks, title, and whether multiple entrepreneurs were involved. So the thing I would highlight is that whenever you have a large data set, even if you have a large data set, you want to take a look at specific rows to develop an intuition of how the data set is structured, and to get a better sense so that it facilitates your analysis later on. So in the same way, suppose you want to see the tail end of the data frame, not the head. For that, you just type in tail, and then you run it, and then you get to see the last 5 rows of the data set itself. So you've seen the head, and then you've also seen the tail of the data set right now. So Suppose you want to just see the specific columns, right? The way that you do that is you say print data frame df dot columns, and this would just output the specific columns that you have. So you have columns like deal, description, episode, etc. Now, suppose you are unsatisfied with the name of a column. Sometimes the data set that you get, the columns aren't explained properly, they're not intuitive. So let's say in this case, we find that the column website is a bit unintuitive and we want to change it to company website. So it's a bit clearer. So how can we rename a column? So to do that, what you do is you say df, and then you call rename, use the rename method, and then you type in columns equal, and then you need to key in a dictionary where the key value is going to be the name of the existing column. So it's going to be website, and then the value is going to be the name of the new name that we want the column to take. So we can say company underscore website. And suppose we want this change to happen to the existing data frame itself. What we do is that we insert this additional argument called inPlace equal true. So what this does is it makes the change on the data frame that we have itself. So it changes the website column, the name of the column to company website, and the changes happen in place of the data frame itself. If in the case you choose to put false, what happens is that we get a new copy of a data frame where the column value is going to be company website, and then you need to assign a variable to that specific copy. But in this case, we want the change to happen in place within the data frame itself. So we would say in place equal true. So this argument keeps on coming up. So this is a crucial concept to understand. Let's run it again, and let's see the name of the columns, right, before and after we make this change. So if you take a look, before we made the change, it's still, the name of the column is still website, but after we made it, it's company underscore website. So this allows you to tinker around with the column names so that you can make them more intuitive. Now, what I said was the stuff that we're working with Pandas is called a data frame, but a data frame is made up of different column series. So I want to quickly show that, and I want to show you how you can access these Pandas series and how you can convert them into NumPy arrays, how NumPy and Pandas can kind of interact. So let's say we want to find out what our data frame is made up of. We just want to see that it's data frame. So we say print type, and I put the data frame. It says yes, this is a data frame object. But suppose you want to know, what are these columns made up of, right? How could we access that? So to access the specific column, what you do is you type in df square bracket and then enter the name of the column. So let's say we're interested to know what's the type of these columns, and let's just use valuation as an example. And let's say we want to put in type, right? And it's going to print out that it's a series. So a series is like a column, right? So it's a column, and a bunch of series coming together makes up a data frame. Now, what you can do is that I want to kind of quickly show the interaction between NumPy and Pandas. So you can take this data series, this Pandas series, and you can convert it into a NumPy array. So the way that you do that is you say, okay, before that, let me just show you how this Pandas series looks like first, because we haven't taken a look at that yet. So let's print out so this is how a Pandas series looks like. It's just that specific column. And let's say you want to convert it into a NumPy array. So the way that you do that is you say print, you take that specific column, and then you put dot values, right? And then you run it. Yeah, then you get a NumPy array. So this is like stuff that we saw before. I mean, a lot bigger than the NumPy array, but it's a NumPy array, right? You have an array and you have all these list of variables. Now, I want to teach you how you can access specific rows based on integers and labels right now. So let me do that now. So how can we access specific rows within our data frame? So suppose you want to, so the first method I'm going to teach you is called ILock, and ILock stands for integer-based location. So this is one way to get rows, specific rows that you're interested in. So suppose you just want to get the very first row within your data frame. How do you get that? So you do df dot, and then you call the ILock method, and then you use a square bracket, and then you insert the specific row that you're interested in. So if you're interested in just the first row itself, you put in 0, you run it, and you get just the very first row itself. Right? And this is pretty neat. You see the different column values, and then you see the output. Now, just as with lists, you can get a range of rows. You can get rows and columns as well. So suppose we want to get the first row, but we just want to get the second column, right? What would you do? So like what I said, the first element here is going to be the row, whenever you have a comma. The second element is going to be the column. So in this case, you're going to get the very first row and then the second column. Okay, let's run it. So we get just that one variable here, right? Just get that one output. So this is one way to subset the data. I want to show you a few other iterations really quickly and then move on to how lock works in how you can use location. You can labels to locate variables of interest, rows of interest. So let's say we want to okay. Let's say we want to see all the rows. We want to print rows 2 all the way to 4, and then columns 6 through 9. So how do we do that? So print out rows 2 to 4. Okay. 2 to 4, and let's say columns 6 to 9. So we use the colon operator here, and this should be familiar from the syntax with lists. So we want 2 through 4. We say 1 through 4. So that's when it comes to the rows itself. And then when it comes to columns, we say 5 through 9. So I want to just a quick recap. The end value, whenever you have these kinds of colons, that never gets reached. So in this case, you're printing out row number 1, row number 2. So you're printing out row number 2 first. Wait, let me just clarify this again, because this can be a little confusing. When it comes to Python, because we use zero-based indexing, right? You start with 0 and then you go to 1, 2, 3, and 4. So when I say rows 2, 3, 4, what I mean is second all the way to the 4th one. So I just want to clarify that, just in case there's any confusion. And then in this case, I want it to go from 6 to 9, right? So in this case, we want rows, the second row till the 4th row. So that's going to be stuff here, right? Okay, let me just quickly clarify this. So when it comes to, this is the index. So it starts with 0, 1, 2, 3, 4. But this is going to be the first. It's going to be the second, third, and so on, right? So we want second to 4th, right? We want stuff starts here. It's going to be the second, third, and then the 4th. So that's the reason why we have number 4 here. This value never gets, the stop value never gets reached. So that's something that I want to clarify real quick, just in case there's any confusion. So let's print this out, right? And then you get just this second to 4th row, and then column 6 to 9. So this is a way of slicing the data. But the thing the things that you would have probably realized by now is that when you use integer-based slicing of data, it's not very intuitive. What does row 1 mean? What does column 5 mean or column 9 mean. It's best if we can use the specific string value itself, the specific label itself. That makes it a lot easier to splice the data to get the specific rows that we're interested in. So let's say we want to print out just all the rows that belong to the electronics category. So remember, we have this category column, and there are lots of different categories, and electronics is a category that's represented in the data set. So suppose we just want to get those values. How can we do that? So suppose we want all the rows which belong to the electronics column, right? So the way that you do that is you say print df, and instead of ILock, we use lock. So this is using a label to locate specific rows of interest. So we say df.lock, and then you need to put in a square bracket. And then in this case, when it comes to the rows, we want to make sure that they match the electronics column. So the way that we do that is we say df, and this is going back to the Boolean filter that we learned about previously, df filter. So df category is equal to electronics. So these are the specific rows that we want to be pulling out. And then for columns, let's say we don't want to get all the columns. We just want to get, let's say, the valuation, title, location, and deal. So in that case, we enter those specific labels that you want to get from the column side: valuation, title, let's say location, and whether deal did in fact happen. Okay, let's run this. So now what's going on is we are just pulling out these specific rows which equal to electronics, meaning these are deals that were electronics based. So that's the row base filter that we have. And then for the column side, what's going on is you're pulling out just the valuation, title, location, and whether the deal did in fact happen or not. So those are the specific columns that we are. Oh, wait a second. Okay, give me 1 second. Okay. There seems to be some syntax error here. Let me check that real quick. Okay, give me 1 second. There's a syntax error here. Let me pull that out real quick. Give me 1 moment. Okay, give me 1 second, guys. Give me 1 second. Okay, so in the interest of time, I'm going to show you the next concept, but I'm going to get back to this. There's a syntax error here I need to debug real quickly later on. So I'm going to move on. I'm going to show this later. I'm going to clarify this later in the email. So so we're not printing out just the specific labels here. So I'm going to debug that later and then show you. So suppose there's another way you can. I mean, there are other ways of using lock as well. Suppose we just want to print out the rows in which the valuation is less than 1 million. So the way that you do that is you say print df lock, and then you say, look, I just want to print out valuation where it's less than 1 million. So the way that you do that is you type in df valuation, and it needs to be less than 1 million. It's 1,000, 1 million. So now what happens is you're just going to print out the specific rows in which the valuation is less than 1 million, right? So these are the rows in which specific deals in which the valuation is less than 1 million. Right? If you want it to be greater than 1 million, you just have to change it around, and then you get the specific information. Okay, so I want to move on and teach you how you can perform mathematical functions on the on data frames itself. So let's say you're interested to find out more about this valuation. Let's say you want to find out more about this valuation column. Let's say you want to find out things like mean, median, maximum, and min. So the functions that we're going to use when it comes to pandas are kind of similar to what we have in NumPy as well. So let's say we want to find out mathematical functions. Okay, so let's say we want to find out the mean of all the valuations. So how can we do that? So we say print, and we say df valuation, right, dot, and then we key in the method. So we want to find the mean, we just type in mean. So this is the mean. And let's say I want to quickly run through the other functions that other methods that you can run. You have things like median, you can find the median. So the median valuation is 1,000,000. You can find out the standard deviation, which is essentially a measurement of the spread of the data. You can also run other methods like max, and then min as well. And then if you want to, you can also count the number of rows here. So for that, you run the count and you find that it's 495. Now, the thing I want to highlight with count is that if your row is in fact empty, it's not going to count that. It's not going to count that. So let's say we type in company website here. So the thing is, not every company has a website that's registered in the data set. That's going to, oops, let's type a count here. So that's not going to be 495. It's going to be 457 because not every company has a website listed in the data set. I want to teach one last concept, and then we can do a small exercise. A very neat method when it comes to data frames is this method called group by. It's super helpful. I want to show you how that works. So for those who are familiar with pivot tables, group by is a little bit like that. So let me quickly show you how group by works. So when it comes to group by, let me give you an example first, and then let me explain how it works. df group by. So whenever you want to group by, what's going on is you are essentially aggregating all the data based on specific columns. So let's say I want to find out the median valuation of companies that belong to different categories. So is it electronics-based company? Does it have a higher valuation than a consumer project, a consumer venture? So for that, what I do is I say group by, and then we start with this, okay? And then we insert the specific column that we want to group the variables by. So in this case, I want it to group by category. So what's happening when I do this? So so there are all these different categories, right? Consumer goods, mobile applications, electronics. When I say group by, it's going to aggregate all the rows that belong to the electronics together. It's going to aggregate all the rows that belong to consumer goods. It's going to aggregate along the specific column of interest. Okay, and let's say I want to get the median, right? So for that, I put dot median, and I just want to get it for the valuation. I just want to, so let's just run this first, right? And I want to show you why we need to change it a little bit. So when you just say group by dot median, what's going on is that it's going to find the median for all these different columns as well. So it's going to output a data frame. But instead of this, we are just interested to find out the valuation. So for that, what we do is, we subset. So we just get that specific column. So we say square bracket, and then we get the valuation. Right now, what's going on is we are finding the median valuation of companies across these different categories. Right? Alcoholic beverages, it's about 6 million. Automotive, it's about 6 million. Yeah. So you see all these different numbers, right? But the thing is, this isn't super helpful because it's not sorted out. So if you want to sort it out, what you do is, and because yeah, you want to sort it out. That makes it a lot easier. So you call the sort values. Okay, let's run this first. Okay. Now it's sorted in ascending order. It starts with the smallest value and then it keeps on increasing. So you find that uh, you can see which categories have the highest valuation. But suppose you want to have it in descending order. What you do is you say you key in the argument ascending and you make it false. Then you run it. Now you have it in descending order, and you find out that when it comes to mobile applications, they have the highest uh, valuation. Now I want to quickly do a mini exercise. I know we're running out of time. I want to quickly uh, give you a couple of practice questions to practice, and then we can share, and then we can discuss the code here. So here are the questions. So so I want you to explore, right? When multiple entrepreneurs are involved in a project, is the median valuation higher? That's one question I want you to explore. The next question is, has the median valuation of companies increased or decreased across the seasons? So we have data for 6 seasons. It isn't fully exhaustive, but we have data for 6 seasons. Find out if the median valuation has increased or decreased across seasons. And the last question, if we do have time, is companies based in which locations have the highest median valuation. So take about, let's say, about 5 minutes or so. Work on the first 2 problems, and if you have time, work on the second, and then I'll run it through, and then we can wrap this class up. And if you're done, go ahead and share your code with me and the rest of us in programming exercises so that we can take a look at it. Okay, take another 3 more minutes. Okay, take another minute or so. Try to wrap up what you can, and then I'll explain how you can approach these questions. Okay, take just one more minute, and then let me explain how you can approach all these questions. Okay, so let's get back. I want to quickly, I just remedied the issue that the small syntax bug that I had with the lock section. So I accidentally inserted a square bracket here. So I think the takeaway here is that when you have really long lines, it's difficult to keep track of the square brackets and your parentheses. So make sure you keep track of that. So going back, I just want to quickly explain that just in case there's any confusion. So when it comes to lock, let's say we want to just pull out rows that belong to the electronics category. So you insert df, insert the column you want to check, equal, and then the variable that needs to match electronics here. And then you put a comma, and then you insert the names of the columns that you're interested in. The mistake that I made was I accidentally inserted a close bracket here. So that was my mistake. Right? Sorry about that. But I just wanted to clarify this real quick so that you understand how you can use lock. Now, getting back to the specific questions that we were working on just earlier, let's take a look at it. So the first question is, when multiple entrepreneurs are involved in a project, is the median valuation higher or not? So the first thing you want to do is whenever you have these kinds of problems is to just take a step back and you want to think, okay, wait a second. We know that we want to group the category, we want to group the rows by whether multiple entrepreneurs were involved in the project or not. So what could be the potential column of interest be, right? The first thing you want to do is you want to take a look at all the columns first, right? df.columns. And then you find out that there's this column called multiple entrepreneurs. And if you had taken a look at it, you would find out that it's either true or false. So meaning, it indicates whether multiple entrepreneurs were in fact involved in the project or if they weren't. So that's the variable that we want to group by. So what we do then is we say, look, let's print df.group by. Okay, we want to group by, and then we want to insert the specific category that we want to group the results by, and in this case, it's going to be multiple entrepreneurs. You need to make sure that it matches the specific column itself. And then you want to put median. So we want to find the median valuation. And we just want to get the valuation column from this specific data frame. So we just say valuation. So it's printed out. You don't need this anymore. Right? So what do you see? When multiple entrepreneurs equal true, meaning when there are multiple entrepreneurs, the median valuation is 1 million. But if multiple entrepreneurs aren't involved, meaning there's a solo entrepreneur, the median valuation is just 800,000. So that's the answer to that question. The next question is, it's an interesting one. Has the median valuation of companies increased or decreased across seasons? So now, once again, you want to think about, okay, what's the specific column that we need to be grouping the results by? So in this case, you locate the variable that you want to look at. You want to aggregate the results by its season. So you do something similar. Let's just copy the code in the interest of time. And instead of multiple entrepreneurs, you can say season. Okay. What do you find out? You find out that across seasons, it has actually increased. I mean, it isn't completely uniform. Oh wait, it has increased. Yeah, it has increased generally speaking, but the second season, the median valuation was less than the first season. But broadly speaking, you do find that the median valuation has been increasing along the seasons. So as time has passed, the median valuation of companies has increased. The last question was, companies based in which locations have the highest median valuation. So in the interest of time, let's take this out. Let's put in location. We know that the variable is location. Location. And let's look at this. Okay, we want to sort the values here because we have a lot more. So we go back here and we say sort values. And then we want to say ascending equal false. Right? You run that. Let's comment all of these lines out. Okay, so you find that Santa Rosa, California has the highest median. Companies based there have the highest valuation, and then it starts decreasing from there. So another interesting question that you can ask and we can explore just very quickly is, where are most of these Shark Tank ventures based, right? So for that, instead of median, we need to use count. So companies based. So the question is, we want to do a location frequency count. So we group by location, but instead we do count. And because this is going to be, so let me explain this. So we want to count, we want to classify it by locations, right? We want to find out, okay, how many companies are based in Athens, Georgia, or Tulsa, Oklahoma. But the thing is, we don't want to print out every single row, every single column in the data frame, so we just use valuation. So let's run this now. And then you find out that Los Angeles, LA is most frequently represented, followed by New York and San Francisco. So I just want to give you a quick sense of the kind of grouping that you can do to make sense of the data. So wrapping up the class right now. So what's next? So I'm going to be posting the class notes in the form of a Python notebook on the class announcement section after this. And the thing is, so I've been running this for almost a year right now, and last week I offered a class as well. I want to hear your thoughts about future classes. What kinds of classes do you want? Do you want classes to be longer or shorter? Do specific times work for you or not? So just direct message me on our Discord server app. So hit me up. I want to learn more about the things that we can do to make these classes better. And the thing is, right now I'm planning to offer more data visualization and intro to SQL classes. I want to hear if these are the classes that you are interested in. And next week I'm going to be taking a break. But after that, whatever future classes that I offer, if you opted in to learn more about those classes, I'm going to be sending the information your way. And if you wish to support me and you want to get support these classes, what you can do is that you can leave a tip at Venmo at gpal09. Otherwise, you can also go to this link, buymeacoffee.com/gpal. And that's pretty much it. Thank you so much, guys. I'm going to be here in our Discord server app for the next 30 minutes. So if you do have any questions about what we just covered, go ahead and ask me there as well. So that's it. Thank you so much.